The last section of the lecture this week really pulls everything together that we've reviewed today and shows what we have learned from climate predictions. Climate predictions can be simple. This slide compares predicted temperatures in 2100 for RCP 2.6 in blue and RCP 8.5 in red. The y-axis is temperature and the x-axis is time, going from 1950 to 2100. The black line shows actual observed temperatures from 1950 to 2005. What is the temperature in 2100 for each scenario? For the RCP 2.6, it is 1 degree Celsius, and for the RCP 8.5, it is 4 degrees Celsius. Do you think this difference matters? Why? Which representative concentration pathway do you think we should be trying to follow? Yes, I think the temperature difference really matters. At the Paris meetings in 2015, 195 countries agreed to work towards keeping global temperatures well below 2 degrees Celsius. Why 2 degrees Celsius? Scientists argued that if global temperatures rose more than 1.5 degrees Celsius, the world would face grave consequences. A compromise to get an agreement put the goal to well below 2 degrees instead of 1.5 degrees Celsius. However, in 2018, the IPCC released a special report that, based on new data, pushed countries to aim for 1.5 degrees C or less. We will talk much more about what is meant by grave consequences in Lecture 9 and 10, but a major concern is rising sea levels, which would threaten coastal cities. Scientists can use inverse calculations to determine emission scenarios to keep temperatures below 1 to 2 degrees Celsius. Using this approach, a stabilization of atmospheric carbon dioxide concentrations is determined that would prevent warming above a target of 1 to 2 degrees Celsius. From this, allowable emissions are estimated, and then forward calculations are used to determine the climate outcome. As you'll have learned from playing with a simple climate model, it's very important to differentiate between stable emissions and stable atmospheric CO2 concentrations. Stabilizing emissions means we stop increasing our emissions, but we continue to emit at a particular rate. Right now, we're emitting at about 11.2 gigatons of carbon per year, so that would mean we would be continuing to emit at that rate. Because of the residency of carbon dioxide in the atmosphere, stabilizing emissions does not stabilize the concentration of CO2 in the atmosphere. The only way to stabilize CO2 in the atmosphere is to cut our emissions. This slide illustrates what we refer to as climate commitments. This is the amount of change we are already committed to. Note carbon dioxide emissions in yellow. They peak in about 2050 and then drop to zero. However, the concentration of carbon dioxide in the atmosphere continues to increase before stabilizing about 100 to 300 years later. Temperature follows atmospheric CO2 concentrations, while sea level continues to increase and only stabilizes hundreds to thousands of years later. Owing to the residency of carbon dioxide in the atmosphere, this means that the effects of our carbon dioxide emissions today will be felt for generations.